So I have here 3 different compounds. We're not going to worry about naming these compounds. We're going to focus on being able to identify if they are rectus or sinister, just if they are right turning or left turning. Okay? So in each one of these, I have 2. I have at least 2 stereocenters. On this one, they're both alcohols. On this one, I've got an iodo and a chloro. Notice that this methyl and this methyl are the same, so this is not a chiral center. And then on this one, I've got an amino and a hydroxyl. So let's go ahead, let's start with this one, and let's just number the priorities of each attached group. So this is my chiral center that I'm looking at here. Chiral center right here. And here I'm going to have an oxygen, carbon, and carbon. Okay. We'll have to think about that. And then I'm going to have a hidden hydrogen. Fortunately, that hidden hydrogen is facing the back, so this will actually be pretty easy to figure out. First, I need to figure out my atomic numbers. And to do that, I'm going to notice that I've got a carbon here and a carbon here. So I'm going to have to do my naming trick, my numbering trick, where I'm going to go to all of the attached pieces to that carbon. So this is a carbon, but it's attached to a hydrogen, and another carbon here. This one is attached to a hydrogen, hydrogen. Okay. So this one beats this one. Great. So if we're numbering our atomic numbers, oxygen has an atomic number of 8. Carbon has an atomic number of 6, with this one winning out. And hydrogen has an atomic number of 1. So we'll make this our 1. This will be our 2, 3, 4. Okay, simple enough. And with that numbered, I can see my direction is clockwise, or going to the right. So this would be the R orientation for that chiral center. This one here, I'm going to do the same thing, except this time I have my hydrogen. My hidden hydrogen is facing forward. Okay. So this carbon is going to end in 3 hydrogens, just like this one did. This carbon is going to go over here, is going to be ending in carbon with 2 hydrogens, just like that one did. They'll be the same. Let's draw that out anyway. This is red again. So it'll be H, H, H. There we go. This one is just the opposite direction, so going this way, it's also a carbon, but those hydrogens are still there. Okay? So there's a carbon, oxygen, hydrogen. So all the same groups, and they'll get numbered the same way, with my oxygen being number 1, this carbon here being number 2, and this carbon here being number 3. And then my hydrogen is 4. Unfortunately, I can't just draw a circle around this because my hydroxyl group is facing into the board. I need that to be facing outward in order to figure it out. So I'm going to switch it with this hydrogen. So if I switch these two and say that this is number 1, then I would go 1, 2, 3, and I would get the S orientation, which means that since I flipped these, this is actually the R orientation. Once again, okay, so these are both R. Fantastic. So if we were to name this, it would look something like 1R or R1 and R1, 2, 1, 2, 3, 4, R4. Like that. And then we would tack on the rest of the name, just like we did when we were looking at Entogagin and Zusammen. Okay? Let's look at the next one. I've got an iodo and a chloro group. Now, these are also going to have hidden hydrogen, so let's draw those in. It's going to have a little hydrogen right here. And a little hydrogen right here. All right. Both of those hydrogens are facing forward. So both of these will be the reverse. We'll have to reverse that. So let's take a look. I've got here, coming from here, I've got an iodine, hydrogen, carbon, carbon. So we're going to need to look at what those carbons are attached to. Let's use blue this time. This one is attached to 3 hydrogens. And I can see what this carbon is attached to. It's attached to another carbon here, a hydrogen, and a chlorine. Well, that is definitely going to beat that. Okay. That was simple enough to figure out. So in that case, let's use red. In that case, my iodine, having an atomic number of 53, is definitely going to be number 1. My carbon that has the chloral group on it, that's going to be number 2 because chlorine beats all these hydrogens. So that's 2. This would be 3, and this hydrogen is 4. Once again, that hydrogen is facing outwards, and the iodine is facing in. So I need to flip those. So I would flip these two to figure it out. And if I flipped them and made this number 1, then my direction goes clockwise, which would be R. Therefore, because I flipped it, I flip it back now, and it's S. So this would be the S orientation. All right. Looking at that chloral group right here, let's erase this arrow just so we can see it a little better. Get rid of these. This is going to get in our way. So looking at this chloral group here, that's again facing into the board. I'm going to have a carbon here, and this carbon is attached to a hydrogen, hydrogen, and a carbon. This carbon right here. This carbon is going to be attached to an iodine, hydrogen, and another carbon, so carbon here. So this carbon is definitely going to beat this carbon. So if we go through and number these, chlorine has an atomic number of 17. That's going to be our number 1. This carbon is attached to an iodine, carbon, and hydrogen. That beats 2 hydrogens and a carbon, so this will be number 2. This carbon becomes number 3, and hydrogen dead last at number 4. Great. So now, once again, I need to flip this. So my hydrogen and carbon and chlorine, need to switch spots. So then my number 1 would be right here, and I would go 1, 2, 3 to the right, which means that flipping this back, that would be sinister. That would be to the left. There we go. Okay. It's not too bad. It's not too terribly bad. For our last compound here, I've got an amino group and a hydroxyl. Let's draw in our hidden hydrogens. So here on the hydroxyl group, my hydrogen is facing backwards. On the amino group, it's facing forward. So let's go ahead and figure out our stereochemistry for this one. So I need to first, let's not use blue, the amino is blue, let's use green. I need to first figure out my priority for each one. Now nitrogen comes in at number 7. This is hydrogen, there's a carbon and a carbon, so clearly nitrogen is going to win. Carbons are 6, so there's my 1. Clearly hydrogen is going to come in last, so that's going to be 4. So I just need to figure out what this carbon and this carbon are going to be. In order to do that, I'm going to find the first point of dissimilarity between them. So notice it's the same right here. Both have a hydrogen and another carbon. Hydrogen, hydrogen, another carbon. So we're going to go to the next point. That's this point and this point here. That point, this point. So I'm now looking at what those carbons are attached to. This carbon is attached to an oxygen, a hydrogen, and another carbon. This carbon is attached to a hydrogen, hydrogen, and that same carbon. Well, oxygen then beats carbon, okay? So oxygen here beats out, well, the O, the H, and the C combined beat out the H, and the C, okay? So then this one, this carbon, that's my number 2 priority. This one is my number 3. And when I do that, this is flipped the wrong way. So I need this hydrogen to flip with this amino. So I'm going to flip them back. So 1, 4. And now this would be 1. And I would go clockwise. And when I flip it back, that means that this would be counterclockwise, being sinister. So there we go. It's the S conformation. Now, got the hydroxide one. Now, this oxygen is clearly going to come in at number 1, because this is a carbon, this is a carbon. Oxygen has 8, carbon has 6, so there's my number 1. My hydrogen is 4, facing into the board. That's exactly where I want it, so that'll work out nicely. Now I just need to figure out the priority differences of my carbons. So once again, these two carbons are identical. So I need to go one more out. So now I've got hydrogen, hydrogen to carbon versus hydrogen, nitrogen, carbon. Well, CN and H beats CHH, right? So this carbon right here, this guy, is attached to a C, an N, and an H. And I'm comparing that with this guy, who is attached to a C, H, and H. C and H, that would be 6, 7, and 1, beats 6, 1, and 1. Just like if we were playing cards and I had a hand with these numbers, I would beat these numbers. Great. So that means that this carbon has a higher priority, meaning this carbon has a higher priority, and it is the 2 once again. And this is then the 3. So I go 1, 2, 3. I'm going counterclockwise, and that means this is the S. Fantastic.